my name is Cedric. I'll be doing the Fluent Project 2 for Ozbay. Start with the geometry, new design modeler. Wait for it to come up. Alright, we'll be working in the XY plane, so get that oriented there. Start with sketching, rectangle. Try to start at the origin, makes it easier later. And for dimensions, we'll start at the corner here and here. That'll give us the length of the flat plate. We'll start here, and that'll give us the height of the area we want to observe. So for the length, it's 100 centimeters, which is 1 meter. So there. And for the height, we'll make it 0.5. Alright. And this will give us our area of interest here. And for the sketch, we go to create surface from sketches, click apply, and then click generate, and that'll give us the surface right here. Next part, we want to do the geometry, go to mesh, starting mesh. Wait for it to come up. Alright, get that oriented. Mesh, we go to insert face meshing. Click it, apply, and generate. Alright, give it time. Okay, so that gives us our face mesh. And in order to get the mesh to look the way we want it to, we're going to do insert sizing. I'm going to click, going to do the edge select, click here and here, and we'll do apply and change this to number of divisions. For this we'll do something like 50, and for the capture curvature we're going to change that to no, and the behavior to hard, and then click generate. Okay, that does this to the mesh, and we want to make the mesh so that the smaller parts of the mesh are down here, while the larger ones are up here. So we're going to do another sizing. Click on this edge, apply, number of divisions, and for this we'll do something like 60. Capture curvature. No, change that to hard, and for the basis we're gonna change it to this one here, and it's gonna ask us for the basis factor. We'll do something like 70, and that gives us what we want to see for this edge at least. So we click generate, and yeah, it gives us what we want on this edge, but it's still not what we want to see on this edge. So we're going to have to do another sizing for the other edge. Okay, click here. Change number of divisions. Again, make sure the number of divisions are the same as they were on this edge. Curvature, no. Change this to hard. Basis type, same kind of basis as the other edge, and the factor is going to be the same. And yeah, so we see that on this edge we have the larger ones on the bottom and the smaller ones on the top. We want that reversed, which is also why you don't do both edges at the same time. So we'll click reverse basis at the edge, apply, and yeah, that gives us what we want. So we click generate. Yeah, and now this is what our mesh should look like. So now We select the edges and we create name selections for each of them. You can do that by right-clicking, create name selection, or you can just press the N key on the keyboard. So for this top one, we're going to name it the far field. This bottom one, I'm going to name the plate. This left one is going to be the inlet. And this right one will be the outlet. Okay, and we can see our name selections here. And we can name the body, we can name that the airflow. Okay, and we can see all our sizing and all our name selections, and that should be everything for the mesh that we need. Mesh, make sure to update it. That'll give you the check mark here. Then we go to setup. Alright, it's going to ask you for the processors you want to use and all that, so I use double precision and 6, and click start. Just wait for it to come up. Full screen, and one of the first things I do is go to results and set the residuals, change it to 1e -6, just to make the results more accurate. Okay, and for this project we're going to go to models. We want laminar flow, so we change the viscosity, change it to laminar right here. Click OK. And the materials for the fluid, we want air, we want to check, make sure it's the properties we want. Okay, so in this case we want, for the density we want 1.2, and for the viscosity we want 1.8. Click change and create. Okay, now for the boundary conditions, the inlet, I want to change the velocity for that. We want the velocity to be 2 meters per second. Apply, close. Outlet, gonna be fine. Wall. Now, far field and the plate. Now for this, for the far field is going to treat it as a wall. We don't want that. What we want is to change this to symmetry right here. Click apply. And that way it'll just kind of ignore the top part and not treat it as another kind of plate. And for initialization, we can change that so that the number of iterations, I usually change it to something like 15. Click apply and hit initialize. Just wait for that to come up. Okay, and we see the initialization is done. Then we do run calculations. And we have number of iterations. I changed that to 150. You can do however many you want. And then we hit calculate as soon as this thing is done doing what it's doing. Yeah, so we hit calculate. And then we just let it run and do its thing. calculations are done, you'll get a message like this. Okay, and you'll get a graph like this. And to find the velocity, we go to plots, XY plot. And for the velocity, we uncheck position on X and position on Y and change the plot direction 0 to the X and 1 in the Y. And this will make it so our Y-axis is the height of the area of interest, and we change the X-axis function to velocity magnitude, and that'll make our X-axis the velocity, which should give us the velocity graphs for the boundary layer. And we want the velocities at certain X values, so what we're going to do is go to new surface, make a line, and this way we can set the start and end points of the line. In this case, we want 1 at X equals 25 centimeters, so X0 will be 0.25, our Y0 will be 0, our X1 will also be 0.25, and our Y will be the height of the area, which is 0.5. Click create, and we're going to do this 2 more times for 50 centimeters and 75 centimeters. So all we really do is change the X value, since that's really the only thing that changes. And so okay, select those 3 lines, and probably could have renamed them to like something like centimeters 25, centimeters 50, centimeters 75. But we do that, we plot it, and this is our velocity magnitude graph and we can, if you want a closer look at what's going on, you can zoom in, and you can see how they separate at the end. And to extract the data, we go to write to file, write. We're going to save it to the desktop, and we're going to name these velocity magnitudes. I'm going to hit OK, and then that'll be on the desktop. And for the contours, we're going to go to graphics, contours, new. Name this one to velocity, and we'll just have it be the contour of velocity. And we don't want to select any of the surfaces, and click save and display. Yeah, and you can see down here the boundary layer where the velocity is 0, and then the velocity is around 2. And it says 2.6, but that's because with the simulation there's some velocity overshoot. You can see right here too. And we're going to do the same for things like pressure, and the static pressure, dynamic pressure, total pressure. And you can screenshot this if you want, and then we can do the pressure. Pressure. Static pressure, pressure, static pressure. Don't select any of the surfaces. You can see zoom out. This thing's being stubborn, but you can exit out of that, hit save and display again. Yeah. Okay, here we go. And you can see where the static pressure is highest here. That's where the air is hitting the plate head on, and then the rest is just the air moving, so there's low static pressure. And for dynamic pressure, it should look like the boundary layer without this part here. Yeah. For the total pressure, it should just look completely, similar. Now to get the drag coefficients, we go to reports, new force, go to drag, over the plate, it's okay. And it'll show you right here the drag coefficient to the plate, 0.01538. So this. And to get the skin friction and the wall shear, go back to the XY plot, new, name this one. Wall shear. Go to wall fluxes, it'll say wall shear stress, and select the plate and hit save and plot. Yeah, and this is the wall shear stress over the flat plate. And for the skin friction coefficient, just select the skin friction coefficient from the drop down menu and hit save and plot. And it's pretty much the same graph. And go to reports again. New. This should. Yeah, this will give us the actual value of the wall shear and skin friction, so click OK.